Good morning, everybody. So, now that we have gone over climate and climate change, we're going to be moving into our last unit of the year, forces in motion. Today, I'm going to introduce you to a bunch of the vocabulary that we talk about with forces in motion, and then we'll go into more details and examples as we move through the lessons. So, what is motion? You can see the bullet over here is in motion, as well as the parts of this apple. That car is in motion, and this person is in motion. So, motion is when an object moves, and it's caused by what it is a change in position over time. Now, when you are looking if motion is occurring, you look at this reference point. The reference point here is this tree. It's an object that we're going to compare to measure movement. So now that we've seen that the car has changed in reference to this point, that tree, we can tell that it is in motion. You have to have a reference point to know if something is moving. Now, speed and velocity are different things, and we're going to go over that. So, speed is how fast an object moves. Okay? That means we're taking its distance and the time it takes to travel that distance. When you divide the distance by time, you get speed. Now, this could be going in any direction. It is just taking how far you've gone and dividing it by the time. When we talk about speed with cars, we normally do miles per hour. In other parts of the world, they do kilometers per hour. In most scientific problems in your future, you're going to be working in meters per second because meters is the distance divided by the time that would be in seconds. So when calculating speed, we take this 400 meters that they travel in the dash and divide it by the 58.6 seconds. And that would tell us that they are moving at a speed of 6 and 83 hundredths meters per second. What that means is that every second, the athlete is moving 6.83 meters. Velocity has to do with speed, but it is different. Velocity is speed, but with direction. So if you're talking about velocity, you have to specify in which way that object is moving. You have to specify the direction. So speed would be 55 miles per hour. Velocity would be 55 miles per hour north. They are moving that fast in the northern direction. 19 meters per second is the speed, but when you specify the direction, 19 meters per second to the right, that is now velocity. Velocity has both speed and direction. The direction is what changes it from speed to velocity. Acceleration is different than velocity and speed. So acceleration is a change in velocity. Now this, since velocity is speed and direction, it could be a change in the speed or the direction. This would be measured in meters per second squared. It's meters per second times seconds. So when you press on the gas pedal in a car, it goes faster. That is a change in velocity. As you're moving forward, being the direction, you are now speeding up. An increase in speed means that you are accelerating. When you are on the highway and you are going the same speed in a straight line, you're not changing your speed on the speedometer. You're going 65 miles per hour the entire time. There is no acceleration. You have a constant speed. There's no acceleration because your speed isn't changing. The second you hit those brakes, though, or stepping on the gas and you just start slowing down, that is also acceleration because it is a change in speed. It doesn't matter if it's an increase or a decrease as long as the speed is changing. So here are some examples. You start off at 30 kilometers per hour and speeding up to 60 kilometers per hour. That is acceleration because the velocity increased. Here, you're starting at 60 kilometers per hour and you're ending at 60 kilometers per hour, but you went around a curve. This is also acceleration. The speed didn't change, but the direction changed. So acceleration is a change in speed or direction. So this is also acceleration. You're accelerating to the right now. And another example would be starting at 60 kilometers per hour and then going all the way into a stop to 0 kilometers per hour. This is an acceleration because the speed has changed. You went from 60 to 0. So acceleration can be a decrease in speed and a decrease in velocity. But when it's decreasing, that is known as a negative acceleration or decelerating. So acceleration tells us how the velocity is changing per second. Velocity is speed with direction. So if it's a small number, that means it's going to be getting gradual changes. It's a slow increase or decrease in speed. If it's a big number, that means it's a rapid change. You kicked the soccer ball, that would be a huge acceleration because if you kick it as hard as you can, because it is a huge change in speed. And then a negative acceleration means an object is slowing down. If it's negative, it is slowing down. It's still acceleration because there's a change in that velocity, but it isn't going to be slowing down. When calculating this, you would just take the velocity at the end, subtract the original velocity, and then divide by the time you measured it over. I'm not going to have you do problems like this. So a force is a push or pull on an object. You have heard this a million times, right? A push or pull on an object. This can change its speed. It can either increasing it or decreasing it. Forces can also keep something stationary. And it can even change the shape. Net force is a combination of all the forces acting on an object. So we have this book here, and you have a force going to the left at 20 newtons. Newtons is the unit for forces, by the way, like how meters is for distance and seconds is for time. Newtons is for forces. 20 newtons to the left, 18 newtons to the right. The net force would be U. If they're in the same direction, you add. If they're in opposite directions, you subtract. So it would be 2 newtons to the left. So whichever one is larger has now the net force on that side. And that is going to mean that if there is a net force that is positive or negative, it is going to start moving in that direction. That means it's accelerating in that direction. If the net force is 0, there is no forces, no extra forces acting on it. So if that object was moving, it's going to keep moving. And if it was in place, it's going to stay in place. So balanced forces. Balanced forces. If something's balanced, you know it has an equal amount on both sides, right? Think of those old-fashioned scales, right? If they're balanced, it's the same weight on each side. Well, balanced forces means it's the same forces in opposite directions. And if those are balanced, if those forces are balanced, there's going to be no change in the motion. So if you are pulling on both sides of tug of war at the exact same force on each side, they cancel out and you're all going to stay in place. This person has gravity pulling them down, and then the floor giving an equal and opposite force up. That is going to make it so that they're not bouncing off the ground or going through it. Those are balanced forces because they're the same up and down. There are also unbalanced forces. Unbalanced forces are seen here when you have them only pulling with 50 newtons. Remember, newtons is the unit for force. to their side, the right. But the left is pulling with 100 newtons. They're pulling with much more. So the net force would be this direction, right? 100 minus 50 would be 50 newtons to the left. Since they're unbalanced, they are not the same, which means that the motion is going to change. These people are getting pulled. That rope is going to move to the left because there's an unbalanced force, more force pulling to the left. Here, their forces are the same in the up and down direction. But as you see here, there's not as much force up as there is down, so they're going to slide. These are unbalanced forces. If something is moving, there's a change in their motion in either direction or in their velocity, well, speed or direction, velocity being both, then you have unbalanced forces. And the last thing I want to talk about today is friction. So friction is a force that acts in the opposite direction of motion when in contact. So you have an object and you are pushing it. Friction is the force that is acting against you. So if you have something really heavy and you're trying to push it in that direction and it's not moving, that's because that friction force is the same as your pushing force. Getting a net force of 0, no change in motion. Friction always goes against the way that you're pushing or pulling. So when objects aren't moving when they're on a ramp, that means that the friction is keeping it in place because that's opposing the movement that would be caused by gravity. So those are vocabulary words that I wanted to talk about. Force is a push or pull on an object. Net force is the combination of those forces. Balanced forces are equal on both sides, so the object does not change in its movement. Unbalanced forces mean that they're unequal and that they will change the motion. Friction goes in the opposite direction. And then we have speed, which is an object moving, how fast it moves. Velocity is how fast it moves in a given direction. And then acceleration is a change in that velocity, an increase or decrease in speed, or a change in that direction. Now you're going to do the quizzes to just go over this vocabulary, and you'll be done for the day.